Alright guys, just a quick video on graphing tangent and cotangent. So I am going to keep it very short, okay? So first and foremost, let me give you some characteristics of the tangent, okay? As in y is equal to tangent of x, and then we'll look at the characteristics of cotangent, and then proceed to the graphing portion of this, okay? So first and foremost, when we talk about tangent, guys, tangent has a period of pi, okay? The tangent graph has a period of pi, meaning it repeats every pi units. So it cycles every pi units. Now, the domain of tangent includes all real numbers except odd multiples of pi over 2. And I'll show this to you in a little bit, okay, when I go to the chart of pi over 2, as in pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2, and so forth and so on, okay? Now, the range, on the other hand, has no restrictions. The range is all reals. Now, here's a very important key characteristics with these functions, the tangent function as well as the cotangent function. They have these vertical asymptotes, guys, okay? Oops, wrong ass. I always do this. Okay, vertical asymptotes at multiples of pi over 2. Odd multiples of pi over 2. I don't have enough room to write it on here. That's why I'm just putting pi over 2, but it's multiples of pi over 2. What is an asymptote, you guys are asking me? Well, here it is. A vertical asymptote is a vertical line, an imaginary vertical line that the graph approaches but will never get to. In other words, this is a value where the graph or the function is undefined, guys. So in other words, you cannot find the value of this function on the graph. It is not defined, okay? So the tangent as well as the cotangent, they do have these vertical asymptotes. And then last but not least, the tangent function is an odd function. And this just means that if you were to take tangent of negative x, this would equal to the opposite of tangent of x. Okay, that's what it means. It means it's symmetrical with respect to the origin. It's symmetrical with respect to the origin when it's an odd function. All right. Now, here comes, okay, the cotangent. Now, let's see how the cotangent is different. Let's say y is equal to cotangent x. Remember, cotangent is the inverse of tangent. Tangent is equivalent to the ratio of sine over cosine. So if we're talking about cotangent, the inverse of it, that would be the cosine of the cosine over sine, okay? So let's see how the cotangent differs from the tangent function, guys, okay? So here are some characteristics of the cotangent. So the period, it cycles every pi unit. So it's repeating every pi unit. The same graph is repeating over and over again, every pi unit. Now, the domain of this function includes all reals. Here is the big difference, guys. All reals except multiples of pi's. So except multiples of pi, which means at multiples of pi, pi, 2 pi, negative 2 pi, this graph will be undefined. So you know what that is going to lead to, okay? So let me go ahead and finish up this part right here. The range, just like with the tangent, it's all real, so there's no restrictions in the range. And then last but not least, guys, the vertical asymptotes. Now, when we talk about the vertical asymptotes, just like we did with the tangent, these are imaginary lines which are function approaches, values which are function approaches, but we'll never get to. So for this one, the vertical asymptotes are going to be found at multiples of pi. Yeah, at multiples of pi. So pi, negative pi, pi, negative pi, 2 pi, and so forth and so on, okay? So that's the vertical asymptotes. So guys, we are going to now look at a chart. And then I will go ahead and look at the graphs. I will do 2 examples of the graphs. And then we'll go ahead and talk about this in class some more. So guys, let's go ahead, and I'm going to make this a very extensive chart because I want you guys to understand what's going on. So let me go ahead and set it up for you. All right. We're going to start with sine, cosine x, tangent x, and the cotangent x. So we're going to do a comparison here, okay? So let's start with the values first. At 0, guys, okay? The degree measure or the radian measure, degree or radian measure. Let me put the radian instead. The radian measure. Okay. So guys, let's look at 0. Sine of 0 is 0. Cosine of 0 is 1. So if you think about tangent in terms of sine over cosine, if you take 1, you divide it, 0, you divide it by 1, that's just going to give you 0. Now remember, cotangent is cosine over sine. So this one would be 1 divided by 0. So what would happen here? This would be undefined. Yeah. Okay. So now let's keep going. Next, I'm going to move up to pi over 2. Okay. Now remember, I'm checking for multiple values of radian. Okay, guys. So at pi over 2, sine is 1, but cosine is 0. So tangent becomes undefined. Remember, earlier we're looking at the characteristics, and we said tangent has a vertical asymptote at multiples of pi over 2, odd multiples of pi over 2. So in other words, the domain of this function is undefined at pi over 2. So what's going to happen with cotangent? For cotangent, guys, when you get to pi over 2, it's going to be 0 because that's cosine over sine. Now, let's keep going. So I'm also going to look at the negative part of this too. So if we go to negative pi over 2, think about it. Negative pi over 2, guys. That's the negative side of the y-axis. So the sine x will be a negative 1. However, okay, listen to this one right here. Okay, x, cosine x, will be 0. So tangent will be undefined and negative pi over 2, but cotangent will be 0. Now, let's keep doing this. This time, I'm going to, hopefully my pen will let me write here. Okay, there we go. I'm going to go to pi. Now, we're at positive pi. Sine is 0. Cosine is negative 1. So that would make tangent is 0. And cotangent would be undefined. Okay? So, as you can tell, guys, it's the same thing repeated over and over again. So if we have a negative pi, okay, if we're at negative pi, the sine of negative pi is 0, while the cosine is negative 1. And once again, remember, this is the repetitive nature of these graphs. So this would be 0, and this one would be undefined. All right, let's do just a couple more. And you know what? I'm going to do pi over 4. Okay, pi over 4 is a special case because we're talking about tangent and cotangent. Now think about pi over 4. Pi over 4 is the same thing as 45 degrees. So for pi over 4, sine of pi over 4 is radical 2 over 2. Remember going back to the right triangles. And then cosine of pi over 4 is also radical 2 over 2. So if we take the ratio for tangent and cotangent, both will be 1. And then we might as well do negative pi over 4. And negative pi over 4 takes you into the fourth quadrant, where the sine value is going to be negative, and the cosine value will be positive. So when you take the ratio is going to be negative 1 for both of them. All right? So, I mean, we could throw in 2 more in there, 3 pi over 2, positive 3 pi over 2, negative 3 pi over 2. But then again, guys, it's going to be a repeat of something else we've already seen, okay? You know what? Let's just go ahead and do it, okay? So I'm just going to go ahead and go to 3 pi over 2. Now, think about 3 pi over 2. You're on the negative side of the y-axis. So when you get to 3 pi over 2, guys, okay? Now let's think about this. Sine of x at 3 pi over 2, that's a negative 1. But the cosine will be 0. So when you do the tangent, what is it going to be? Undefined. We've already seen this. Yeah. Okay? And then the cotangent will be? Yes, 0. All right, guys. And then, of course, if you do negative 3 pi over 2, practically the same thing. Okay, negative 1, 0. And this one's going to be undefined. And this one will be 0. Same thing. All right, guys. So I wanted to get these values out of the way. So now that I have these values out of the way, we're going to next graph a couple of these trig functions, okay? So let's go ahead and start with a tangent. Let's do one of the tangent functions, okay? So if we're graphing, let's say y is equal to tangent of, I don't know, just a basic graph. Tangent of x. I'm going to keep it very basic, guys, okay? So we're going to go to the xy plane. Remember some of the characteristics from earlier, guys, okay? And over here, I'm going to be at 0. I'm going to have a pi over 2 over here. And then I'm going to have pi over here. Because over here, I'm going to have negative pi over 2. And then a negative pi. Now, over here is positive 1, positive 2. And over here, negative 1, positive 2, negative 2 along the y-axis, okay? So guys, first and foremost, remember, when we calculate the tangent of pi over 2 from the chart, okay, we found that the tangent of pi over 2 turns out to be undefined. This is where your vertical asymptote, one of your vertical asymptotes is going to fall. Right here at, I'm going to use a different color, at pi over 2. That's a vertical asymptote. Now, what happens if you do tangent of negative pi over 2? Again, that one is also going to be undefined. So over here at negative pi over 2, you also have a vertical asymptote, guys. Yeah. Okay? So pretty much, I think I'm only going to be able to graph one period, guys. But that's okay. I just needed to show this to you. Okay? So now, we know, let's find some additional points on the graph. If we were to do tangent of 0, we know that's equivalent to 0. So there's an x-intercept right here at 0, 0. So then, guys, you need to find some additional points on the graph so you can figure out which way is this graph going. So in between 0 and pi over 2, what do you have? Half of pi over 2, which is pi over 4. Remember, I did that on the chart. So if I were to take tangent of pi over 4, positive pi over 4, that would give me positive 1. And positive 1 is located right about here. Right? Now, if I were to do tangent, this right here is negative pi over 4. So if I were to do tangent of negative pi over 4, this would be equivalent to negative 1. So that would be a point right over here. So guys, we now have sufficient information to be able to graph the tangent function. Now remember, we have the asymptotes. The graph gets closer and closer to the asymptotes, but it will never get there, will never touch it. So guys, when you graph this, this is what the graph is going to look like. It gets closer and closer, okay? That's a little bit of a squiggly there, okay? But it will never get to the asymptote. So this right here would represent one period or one cycle, one revolution, one repetition of the graph of tangent of x. Okay, guys? So, unfortunately, I don't have enough room to go ahead and graph another cycle of it, so I'm going to leave it there. Now, let's go ahead and make the comparison between tangent and cotangent. Now, guys, let's say we just have another basic function. This time it's going to be y equals to cotangent of x. Okay, so when we're graphing the cotangent function, you have to make sure you are very careful with graphing that cotangent function because, remember, this is cotangent, this is not tangent, okay? So first, let's go ahead and go to the xy plane, okay? Now remember, this graph repeats every pi unit. I'm going to drop a negative pi over here. Oops. Oh, Lord. My pen is not writing, guys. Okay. This one repeats every pi unit. And remember, at these pi units, we have asymptotes. Okay. So, guys, let's think about it. Okay. So, if we're to do cotangent of pi, remember, cotangent of pi, guys, would represent the sine over the cosine. The cosine over sine. So cosine at pi would be what? It would be -1. And then sine at pi would be 0. So if you take -1 and divide by 0, what do you get? An undefined value, guys. So it's undefined. So here, you would have a vertical asymptote at pi. Well, what happens to cotangent of 0? Remember, this is cosine over sine. At 0, cosine is 1 and sine is 0. So again, this would be undefined, guys. So right here, this represents another vertical asymptote. Right here is also another vertical asymptote, guys. You see what I'm talking about? So be very careful with this. Now, let's go ahead and find some points here in between, guys. So at pi over 2, which is halfway between cosine, 0 and pi, at pi over 2, if you do cotangent of pi over 2, cotangent of pi over 2, guys, will give you 0. So you have an intercept right here. Same thing is happening over here. As you can tell, guys, I am going to draw the graph of 2 cycles of this, okay? My pen is not writing right now. Hold on a second. Let me try this one more time. Okay. So negative pi over 2, right there. So guys, this is another intercept. Now, you need to figure out how the graph is behaving. So be careful. Between 0 and pi over 2, what do you have? Pi over 4. Okay? So now, we're going to go ahead and check to see how the graph is behaving at the pi over 2 and then pi over 4, guys. At pi over 4, what did we say earlier? It's going to be at +1, okay? Now, over here at negative pi over 4, it's going to be at where? +1 as well. And then, of course, if we were to go ahead and do 3 pi over 4, I'm trying to squeeze this in there, guys. This is not working very well, okay? It would be at -1, okay? So basically, -1, +1 are on the graphs of both cotangent and tangent, guys. So let me try and see what I can do about this graph right here. And this one right here, we're at 3 pi over 4. And at 3 pi over 4, this is not writing very well over here. Okay, so let me go ahead and try this. So there's a point over here and negative pi over 4. Okay, hold on a second, guys. There we go. Okay, at negative pi over 4, we've got a point right here at positive 1, which is not writing right now. Okay, and then over here is where I'm just going to go ahead and drop the marking on there. That's representing the negative 3 pi over 4. So we got another point right there, guys. Maybe I should have just stuck with one cycle, okay? So now, guys, I'm ready to go ahead and graph this. Remember, we have the asymptotes. The graph approaches the asymptote, but doesn't quite get there. So be careful with that. So here's one cycle. All right, right there. You see that? And then we're going to go ahead and grab the other cycle. Wait a minute, I put these points on the wrong section right here. Let me fix that. Okay, so in the case of this one, you're going to have the negative pi over 4 down here at negative 1, and the other one will be at positive 1. So right here is your negative 1. And then over here is your positive 1. And then here comes the other cycle right there. Remember to hit that intercept, guys, and get closer to the asymptote, but not quite getting to that asymptote. So guys, I actually did 2 cycles on this. It does look messy, but the point is you can actually see the different cycles in between. Remember, this graph repeats every pi unit. So you've got a cycle between negative pi and 0, and then the other one from 0 up to pi. Don't forget, guys, when you graph these, pay careful attention to the vertical asymptotes. Pay careful attention to that. So anyways, I'm going to stop here. We'll pick this up in class again and ask questions in class, guys. Anything you want me to clarify for you. Remember, guys, for these functions, we're still following through with the basic characteristics of any of these trig functions. So if you got a tangent of bx, you know, a is the amplitude, b is the period, and so forth. So all of these come into play. But for this, I just wanted to do a basic tangent graph, a basic cotangent graph. So I'm just going to go ahead and leave it right there, guys, because I don't want to overwhelm you with all this information, because that's a lot to take in. So until next time, bye.